Yeah. Hello, everyone. It's the WBC 2022. It's a famous international office. This year, has supported by IMIT. Yes. So I hope we can have a good workshop this morning. Yeah, we can enjoy it. Yeah, because the two people couldn't come here, so they give us the video. Welcome to go to the web chat. Web chat. Yeah. Okay, we can begin. Thank you, Danny.
I come from the School of Civil Engineering, Fuzhou University, Fuzhou, China. The topic of my report is a framework of optimal procurement decision-making of a prefabricated component based on beam component library. This report contains of 4 parts. Introduction, the main problems in the decision-making of prefabricated components, perfecting the conception of prefabricated components, selection decision, and conclusions. Part 1, Introduction. First of all, I would like to briefly introduce the modular architecture. Prefabricated building means that some of all components of the building are produced by a prefabricated component factory and then transported to the construction site, and the components are assembled into a complete and integrated building formed through reliable installation technology and construction machinery. Prefabricated buildings have the following advantages: high productivity, shorter construction period, green environmental protection, and high quality. Fabricated structural members are prefabricated in the factory according to standard models, with a more refined production process and greatly improved component quality. The factory production is not affected by the weather and other natural environment. The construction period is more controllable, and the production efficiency is much higher than that of manual operation. Reduces the discharge of construction waste and wastewater, reduce construction noise, and reduce the discharge of harmful gases and dust. However, due to the imperfected standard system of prefabricated buildings, immense technical level imbalance between market supply and demand and other decisions. And prefabricated construction projects generally have many problems, such as cost increase, extension of construction period, construction the difficulty increases. Therefore, some scholars have proposed a design method for prefabricated building structures and based on beam component library. That is by using standard products provided by different manufacturers in the beam component library. The structure design of a component procurement can be completed quickly and efficiently. Part 2. Main problems in decision making of prefabricated components. The main process of prefabricated building structure design method based on beam component library is shown in the figure above. First, import the beam architecture model and preliminary design stage into the structural design software. Complete a series of structural design and splitting work in the software, and obtain the basic information of each split comment. Secondly, manually select and download the prior component model in the BIM component library, and at the same time place an order to purchase the corresponding products. Finally, update and correct the BIM building model information and deliver the BIM building model to the next stage to guide the construction. The traditional design process has the following problems. It does not comprehensively consider the impact of selection of components from different manufacturers, and it can only randomly select one feasible solution at a time. First, with the increasing types and quantities of components in BIM component library, how to achieve scientific and reasonable component selection decisions on the basic ensuring the smooth development of subsequent stage of work and smooth realization of expected goals has become an urgent problem to be solved. Therefore, it is necessary to efficiently improve the existing prefabricated building design based on BIM component libraries. Part 3. Perfecting the framework of prefabricated component selection decision. Decision system. It consists of 5 modules, which are structure design and splitting model, decision information input model, optimize the program model, optimize the feedback model, and BIM building model delivery model. The import decision-making system has the following advantages. First, optimize and multiply sets of component procurement plans, automatically optimize the components, and efficient decision-making. First is structural design and split model. Based on structural design and split work of the BIM building model, the basic information of each split component is obtained. According to the basic information of split components, confirm whether there is a corresponding component in the BIM component library. If there is a corresponding component, obtain the complete information of the corresponding component directly from the BIM component library, and the complete information includes the production of different manufacturers information. If there is no corresponding component, the basic information including geometry and reinforcement of the corresponding component will be added to the BIM component library. Decision information input model. This model is used to determine decision-making optimization information, and decision makers are input decision-making demand information, such as the cost, construction period, carbon emissions, and so on. And automatically import objectively relevant information, save decision-making demand information, and objective relevant information to the information base. Optimize the program model. A list of optimizations can be provided for decision makers. The model establishes an objective function library, constraint function library, and algorithm library. The objective function library includes several objective functions for different types of decision-making demand information. The constraint function library include several constraint functions for different types of decision-making demand information. The algorithm library includes several optimization algorithms for mathematical models with different characteristics. The type of decision demand information input by the decision maker automatically selects and lists one objective function and lists one constraint function to form a mathematical model. The algorithm library matches the most relevant optimization algorithm according to the characteristics of the mathematical model, and uses the most relevant optimization algorithm, and required the mathematical model is so solved using the knowledge information. And several sets of optimized component pre-calculation plans are obtained. Optimize the feedback model. The optimization plan is determined, and the decision maker determines the final optimization plan from multi-sets of optimized component pre-calculation plans according to objective relevant information, and updates and corrects the beam building model and delivers it according to the final optimization plan. Beam building model delivery model. According to the final optimization scheme selected by the decision maker, the order is automatically placed to purchase the corresponding fabricated component products, and then the corresponding component model is exported from the beam component laboratory library, and the beam building model update and revision work is completed in the beam modeling software, and finally deliver the beam building model in the construction preparation stage. Part 4, conclusions. In general, the main contents of this report are as follows. The study provides a decision method of a prefabricated structure based on beam component library from the perspective of component pre-calculation. The mathematical model required by decision makers is established, and multi-sets of optimized component pre-calculation schemes are solved, which has a positive impact on promoting the development of prefabricated buildings. This reaction needs to be improved and adapted through practice, but it can be regarded as a method to solve the problems of high cost and long construction period of fabricated components. Thanks for watching. Goodbye.
Good morning, I am Lan Jingbing. Welcome to my presentation on an analysis on the existing beam deliveries.
You're muted at the moment.
Hello, everyone. Just now we have got the first the first paper, give us the video. So I want to you know that, for example, 飞页 王晴 and Richard and Lian and Baby. When you pursue your master degree or PhD degree, I hope you can participate in the WBC. WBC, this international workshop or this international conference. It's a very famous conference. I hope you can participate. That's no, you just know you got the information. For example, Fuzhou University, these students use a video to participate in the international conference and show their voice and show their ideas. I think it's a good way. Yeah. If you want to participate and you have the ability to participate, as a supervisor, I will give you great support. For example, that I will pay for the registration trade. For example, if you want to go to the Australia, if the CUVD is we are free of the CUVD, we can go to Australia. We can take you go to Australia. Yeah. So I hope you can report the good information and sound participation from this international workshop. Yeah. Okay, Danny, that's all. Yeah, thank you.
Thank you. So
we can go to the next second. I can go to the second. Yeah.
Yep.
Second video. Yeah.
Hello everyone, I'm Xu Zhenzhen, comes from Shanghai University in China. I'm glad to attend this meeting and meet you here. During the next time, I will introduce research on risk evaluation of logistics park construction project by FEMA based on hesitation environment. The paper can be introduction from research background and the present situation, research count, conclusion and recommendation. Recently, China have promulgated a series of policies which make the construction of logistics park shows a rapid acquisition. Also, high investment, long construction period, and long payback period make the construction of the logistics park a risk. Therefore, it's very important to identify the high-risk factors excited in logistics park construction projects. In this paper, the present situation of the logistics park construction project risk assessment is introduction from two aspects. Allocation index system of logistics park construction project and modeling risk analysis. In order to identify the risk factors, WS method is adapted to consider the whole cycle of logistics park construction projects, which is divided into 3 stages: pre-construction, construction, and operation. 22 risk factors are identified, which are divided into environment, market, technique, management, and economic to establish the risk allocation index systems of logistics park construction projects. Different from the traditional FEMA, this paper adopts the improved FEMA, which combines the dynamic weight adjustment method and further cements. The specific step as follows. First of all, we need to invite an experience to use HULZS for allocation as the original allocation information to construct the elevation matrix. Then, calculate experience weight by dynamic adjustment method, set the initial conditions, establish the college risk allocation matrix. If the constants degree won't contact the initial conditions. We need to modify the risk allocation information until satisfied. Stop and determine the weights of the FEMA team members. Establish the weights risk allocation matrix. Then use FCM to cluster the risks. By this method, the weight of the expert can be calculated, and the risk can be classed instead of simple sortage. HULS can solve the hesitation of expert allocation to verify the reliability of the method. Here, taking Hefei 1 logistics as an example, five experiments are invited to circuit it. The evaluation matrix is shown in the figure. So the result, here we divide the risk into 4 categories, namely high risk, medium risk, low risk, and noise. This is about conclusions and recommendations. This study uses the improved FEMA method to find the risk of the logistics park constructions. This will help the project to be completed in time and with high quality and improve the economic benefits of the project. That's all, thanks.
Danny, we can go back to the second video. This is second video. Yeah, just 2 video or 3 video.
Oh, there's 2 videos.
Just,
Sorry, there's 2 videos. Is that what you're saying?
So there's just 2 video, but we have 5 people. Just 2 video. Yes. Yeah. We have 5 people to share in this workshop. We just got 2 videos. Okay. We can invite Baby. Yeah, Baby to share your paper. Yeah, Baby. Yeah.
Wait a minute. I will share my screen.
Professor Xu, could you help us to share our research here? Yeah, Professor Xu, are you here?
Jing Xiao, are you doing a presentation as well yourself?
I will do the presentation, the last one. I will invite our team member, Professor Xu, to share. Professor Xu.
Hello, Professor Zhang. Can you see my screen?
Yeah, we can see it.
Okay. Hello everyone. The topic of my paper is an indicator framework for assessing the readiness of hospital in the smart healthcare transformation. My talk will be in 5 parts. To begin with background, the development of the smart healthcare system was stimulated by not only the increasingly serious aging population, chronic disease, but response to emergency events. With the aid of information technologies, especially the Internet of Things, 5G, and artificial intelligence, the smart healthcare system is considered promising in enhancing the interconnection of people, improving the efficiency of hospital service, and promoting the satisfaction of patients. For example, the web-based COVID-19 service platform effectively reduced the hospital visit rate. The primary aims of this paper were to identify the indicator framework of the readiness of smart healthcare transformation, check the validity of the indicator framework, and define the weight of each indicator. Examine the readiness of hospital using the evaluation framework. A total of 26 indicators influencing the readiness of smart healthcare systems are identified from a comprehensive review of the relevant literature. The indicators were divided into 3 dimensions: smart facility management, medical system, and organizational management. For subsequent analysis, the indicators are coded as a table. Methodology. The research steps are mainly divided into 4 parts. Step 1, determine the significance of the collected indicators through a questionnaire survey. Step 2, smart software is used to analyze the reliability and validity of the collected questionnaire data. Step 3, significance of the indicators is examined, and the weight of indicators is determined by confirmatory factor analysis. Step 4, the further scientific evaluation methods were used to evaluate the readiness of smart healthcare transformation in a hospital.
Baby, yeah, baby, your slides, we couldn't see your slides. We just see the first page. Yeah, slides. Okay, thank you very much.
Okay, can you see the PPT right now? Okay. The next part, the results. First, a total of valid 186 questionnaire responses were collected. The results show that most of respondents are from university and medical industry, and 3.7% of the respondents had studied smart healthcare for 4 to 6 years, and 43 people had engaged more than 3 projects. On the whole, the respondents had a relatively long research period. The second, the alpha is 0.967, which is greater than the baseline of 0.7, suggests the reliability of the data collected is good, and the KMO value is also greater than 0.7, so the validity of the questionnaire is also good. The third, significance analysis of the indicators. The p-value of KS tests are below 0.05, indicating that the simple data have a non-normal distribution, so that the rest of analysis will conduct by non-parametric method. The results show that the assessment of significance of all indicators is greater than the test value of 3, showing that all indicators were perceived to be critical to the indicator framework. So all indicators are retained. Based on the results, the top 5 significant indicators are medical data privacy protection, medical data storage security, standardization of basic data sets of electronic medical records, construction of clinical service system, and the construction of public service application system, all of which are from medical system hierarchy. The fitting results of the model are shown in the table. We can see the ratio of k-squared degree of freedom is 2.034, and the value of the root mean square error of approximation is 0.075. In addition, the TLI and CLI of this model are both greater than 0.9, indicating that the model fits well. Therefore, the factor loading can be calculated in the CFI model as shown in the table. The factor loading is all greater than 0.5. The weight can be calculated according to the factor loading in the CFA model. Calculation formula of weight as follows. Therefore, the relative weight was obtained as follows. From the result, we can see the weights of Smart FM, MS, and OM are 0.345, 0.324, and 0.331 respectively. Then A hospital was selected as a case. The indicator size and the weight vector are the indicator and weights introduced above. The readiness of A hospital is scored by 5 experts to get the common site. The common site contains 5 elements. The profile of interviewees is shown in the table. Then the single factor evaluation matrix R was obtained by calculating the proportion of scores from 5 experts. And then we can multiply with the transposed vector of evaluation vector R to get the final evaluation score. The score of Smart FM is 3.48, and the score of MS is 3.83, and the score of OM is 3.51. The total score of A hospital is 3.6. And the last part, conclusion. We can the paper the developed indicator framework include 3 hierarchies and 26 indicators. The 3 hierarchies are Smart FM, OM, and MS. And through the significance analysis, the value of fit indicators suggests that the model fits well. And so all 26 indicators are retained. The total score of A hospital is 3.6, indicating that the readiness of A hospital in smart healthcare is above the average. And we also can see that the score of MS is the highest. Is higher than the Smart FM and the OM, indicating that A hospital paid more attention to the application and development of medical technology. However, the hospital should fully develop, including the development of Smart FM and the OM. So it's the end of my presentation. Thank you.
Hello everyone. Do you have any problem? And I have some question. Want to talk, have a communication with Baby, or have a discussion with Baby. Baby, go back to your title. Go back to it. Yeah. Are you focused on the readiness of hospital? Readiness of the hospital in the smarter healthcare transformation. Yeah. Could you give us the specific, could you have or explain the readiness of the hospital? Readiness of hospital. Yeah.
The smart hospital should be intelligence, and the building should be intelligence as well, and the management should be digital, and the medical systems also should be intelligence. So the all aspects work together can make us make our hospital more smart and can
Okay. Sado,
okay. the network has some troubles.
Yeah, 老师。
Do you have any? Do you want to have a voice? Do you want to show your voice with the baby? Yeah. Next time, I hope you can also submit a paper to the WBC for the CIB. Then I will support you to have got a registering, and have a presentation in the workshop and show your voice. Do you have any problem? Or do you want to have a discussion with baby? So indicator framework for assessing the readiness of smart healthcare transformation.
Yeah. Actually, I'd like to ask. Like I didn't see the framework, so I'd like to ask if in her methods framework there's a mediating variable. Or moderating variable. Do you have any mediating variable or moderating variable in your research?
We didn't have the moderate variables. We just developed a indicator framework to evaluation. Yeah.
Oh, okay. So means that in your model, all the effects are direct effect, no indirect effect. Is that right?
Yes.
Okay. Then I get it.
Yeah. You got it. Yeah. Okay. For baby paper, just give the indicator framework. Yes, just show how to got a indicator framework, then to a simple assessment, not use the structure, equilibrium modeling like you. So she didn't use the moderate variable or mediate variable. Yeah.
Okay.
Okay, Danny, I will show our paper just published. Yeah. Okay, couldn't see my. Hello, everyone.
Hi, Loshi. We can still see you.
You couldn't see the paper?
No. We just no. We can't see the paper.
Okay, stop share. We couldn't go to share. Open share. Okay. Could you go to share?
We can see your screen, but not the paper. I think we are not sharing the paper.
Okay, we'll share again. Okay, that time. Okay.
Yeah, now it's okay.
Okay. Hello. Yeah. I just want to show the paper we have published for the international students. It's about the moderating effect of learning experience on learning motivation and learning outcomes of international students. Yeah, we have published in this month. Yes, from our research team. As you know, said, yes, you are also working on this for this international funding. So yeah, for so many more and more international students come to China, they how to got the clear learning motivation and what's the relationship between the learning motivation and the learning outcomes for the international students. Also, really question. Yeah, I really question. So with the increasing level of internationalized in the higher education, so we should to explore the effect of learning motivation on the learning outcomes of international students and the moderating role of learning experience. So we use the example of 130 international students from 23 countries studying in the mainland China. So for this study, it will contribute to the higher education literature on learning motivation, batteries, and learning outcomes. So for this study, we have analysis the background for the effect of learning motivation on learning outcomes. Then we also analyze the effect of learning appearance on learning motivation and learning outcomes. So we got three hypotheses. Hypothesis one is that learning motivation has a positive influence on non-cognitive learning outcomes. Hypothesis two is learning motivation has a positive influence on cognitive learning outcomes. So for the hypothesis three, learning appearance has a positive effect on the relationship between learning motivation and non-cognitive learning outcomes. For the hypothesis 4, it's a summation. So learning appearance has a positive effect on the relationship between learning motivation and the cognitive learning outcomes. So we use this figure 1. This figure shows the learning motivation and the learning outcome. It comes from as input and output for the learning process. It's from this learning process theory. So we can see learning experience as a moderating role to adjust the relationships here. So we use the semi-structured interview to get the date and also got their reviews. So for this paper, we also do the specific data analysis and reliability and availability test. So for the variables, the learning motivation, learning appearance, learning outcomes, this dimension, the numbers. So you can see this is descriptive statistics and correlation coefficients of factors. So we can go to the result. The basic statistics give us the example, give us the results about that. So all the factors include the questionnaire of the study have shows that the learning motivation and the learning experience have the influence on the learning outcomes. The basic statistics show us. So we then go to we can see the findings of the semi-structured interviews. So the participants one said, I like Chinese culture, so I come to Xi'an for study. I learn a lot of knowledge and gained a lot of friends and happiness here. This participants comment just from the left show her motivation. So the motivation for him to study in China, from the fact that he wanted to be exposed to more advanced knowledge about my profession. So this is participant 2. So for different participants, their motivation is different, but they show the high consistency. Yeah, according to the statistics. So for this research, you can see that this empirical study have developed a conceptual model based on the external literature that explores the relationship between learning motivation of international students and the learning outcomes with the moderating role of learning experience. So this study contributes to the literature across a diverse field of research, including the knowledge management, personality-based studies, psychology, and engineering. However, our research also have some limitation. For example, studied comparison of the international students in a single city of Xi'an in Shanxi province. So in the future study, just like we have to the intentional funding side, we hope more and more internations can participate in this funding, then we can broaden it. Then we can go to the general bulletin about the conclusion and have a higher theory could be used in the world wide. Okay. I'm sorry for for participants because I didn't do the slides because I got the presentation. Maybe the time just 1 week. I'm sorry for my work didn't do the slides, so I just shared my paper. Okay, Danny, yeah.
Hello.
Okay, I finished the sharing about the presentation. Yeah.
Yeah, that seems to be all of them for this session. Was there anything else that you had or you wanted to say?
Okay, Saido, Professor Lin, and Rui and Li Yuan, do you have anything wanted to have communication on this workshop? Show your voice or share your idea? Yeah.
Actually, from your presentation, the framework I've just seen. I don't know, is it a framework developed by yourself or is the framework adopted from a previous researcher?
Oh yeah. I can feel that for these 2 months you have got a bigger process to learn the SEM. Yeah. Yeah, from the patient, I got them. I got it. Yes, you will finish it in the maybe 2 weeks. Within 2 weeks, you will finish your paper. Yes. Okay, perfect. Yeah, Professor Lin, do you have anything you wanted to comment and show your idea? Okay, Danny, if there's not yes, Baby, do you want to share idea, Baby? Yeah.
I learned a lot from the paper.
Okay. If there's something, okay, we can come to the finish. Maybe next semester will begin. Yeah. Okay. See you. Yeah.
Okay, Laoshi, see you.
See you.
Yeah, thank you.
Thank you.
I learned from Baby, I learned from Laoshi.
Thank you, Sedo. I'm here. I'm a stick 03. Welcome. Yeah.
Okay.